Hi students, my name is Miss Cassandra Limburg Finance, and in this grade 9 geography lesson, we'll be discussing a very important topic, the structure of the earth. Students, do you know the earth has layers? If you did, have you ever wondered what can be found beneath the earth's surface? Well, in today's lesson, we'll be exploring these layers and noting what they're made up of. Now, the earth is divided into 3 layers. These are the core, the mantle, and the crust. Now, if we think of the earth as a hard-boiled egg, the shell could represent the crust. The albumen, or the white part of the egg, could represent the mantle. And finally, the core could be represented by the yolk. Now we'll go into details about the parts, or these layers of the earth. We'll start with the core. Now the core is located in the center of the earth, and it's divided into 2 distinct parts. These are the inner core and the outer core. The inner core is the innermost part of the earth, and it is metallic and solid, and it composed of an alloy or a mixture of iron and nickel. The temperature in this part of the earth is believed to be about 5,500 degrees Celsius. And if you think of it, it's very, very, very hot. Now, do you know where the heat comes from? Or what causes it? The heat is produced when unstable atoms of radioactive elements like potassium and uranium in the inner core gives off energy. And this is done as the atom seeks to become stable, right? And the energy is given off in the form of waves. Now, what happens in the outer core? The outer core, as we know, surrounds the inner core. However, this layer is liquid in nature. It's also made up of nickel and iron. But unlike the inner core, where there are lots of radioactivity going on all the time, this area is under less pressure. However, the liquid in this section heats up due to the energy coming from the inner core, and as it heats up, it becomes lighter, less dense, and this causes it to rise away from the heat source. This process is called convection. To understand convection and what really happens in the outer core, let's use the illustration of a pot of water on a stove. Here the heat warms the water at the bottom of the pot, which is closest to the heat source. As the water molecules heats up, they become lighter and they rise to the top of the pot. And this is indicated by the red arrows. As the molecules rises, they cool, indicating the blue part of the illustration, the blue part of the pot, right? As the water molecule rises, it cools, and once it cools, it becomes heavy again. It's heavy, so it sinks to the bottom of the pot. This cycle continues, and this is what is called convection currents. This is a fact you should note. The metals in the core gives the planet its strong magnetic field. And again, it is due to the convection currents. The heat also keeps the outer core in its liquid state. Now let's talk about the mantle. The mantle sits above the core, and it is made up of silicate rocks, which are rich in iron and magnesium. This area is predominantly solid. However, in geological time, it behaved as a viscous fluid, being neither solid nor liquid, but in a semi-liquid state. You should know that the mantle is the thickest layer in the Earth's surface, with an average thickness of approximately 1,800 miles. Wow. And it makes up about 85% of the Earth's volume. Note that this layer is divided into several components, 3 of which are the upper mantle, the transition zone, and the lower mantle. As part of the rigid top layer of the mantle, the rocks in the transition zone and the lower mantle, they're always kept in a semi-molten state. And this is due to the high temperature that exists there, approximately 5,000 degrees Celsius. And convection currents are also generated in this layer. Here, the magma or molten rock is heated up due to convection currents. Again, it rises to the top of the crust, cools off, and then sinks back to the bottom of the core where it's much warmer. We'll now talk about the crust. Just above the mantle lies what we call the Earth's crust. This is the thinnest layer. It is also rocky, and it surrounds our entire planet. It is made up of all different types of igneous, metamorphic, and sedimentary rocks. The partial melting of rocks in the upper mantle results in the formation of what is called oceanic and continental crusts or plates. Here's a brief discussion on what is the oceanic crust, what it's made up of, what is the continental crust, and what is made up of. The oceanic crust is the thinnest but denser of the two crusts, right? It is made up of basalt rocks, and they form the ocean basin. I want you to remember, oceanic crust is thinner and denser, right? While the lighter of the two is the continental crust. This crust is also thicker and higher, and it composes of rocks such as granite, and they form our continents. You must remember this, students. These two facts are critical facts that will carry us through our geography lessons. Oceanic crust is thinner and denser. Continental crust, they are higher, thicker, and lighter. Finally, for emphasis, remember that the Earth's crust is broken up into oceanic and continental plates, and note that they are always in interaction, coming together, spreading apart, or sliding past one another all over our planet. In summary, we looked at the structure of the Earth. We identified there are 3 main parts, and they are the core, the mantle, and the crust. We also looked at convection currents and how they influence the Earth. We went through the description and the composition of each of these layers. Now, for your homework, you're required to discuss plate movements. And 2, you're required to identify the different types of plate boundaries and the distinct geological processes and landforms they generate. Now, this has brought us to the end of our lesson, where we looked at the structure of the Earth. I am Miss Cassandra Lindbergh-Finance. See you in our next session, where we'll be discussing another important but interesting topic. Bye, students.